let's go now and go look at. Okay, so we talked about some programming. So I talked about names and you know the importance of choosing names clearly. And I noted that in many programming languages there's grown up to be conventions, not enforced by the language, but that are standard. So for example, C and C++, classes like you've seen in 270 or in uppercases. Functions, methods, or fields with first letter lowercase. Very commonly, you have camel case, which is sort of the separate words are indicated with capital letters. And very often, particularly in Java and some other languages, we have things that are predicates or things that are sort of return a Boolean indicated by beginning with is. Okay, and action methods would do something or given a name like process this or connect to this or what have you. So in short, we have this sort of naming convention that comes up. Constants are commonly for C and C++ in uppercase. Sometimes you have, because they can't use camel case, you can't have lowercase. Have uppercase letters indicating separating words. You have underbars here, and that's all I'll comment on right now with respect to that. But if you see a comment, if you have a pound define of a constant to be some number, for example, you do it in all uppercase, possibly using underbars. Okay. So we talked about sort of ways of writing cleaning code, sort of making things cleaner. I'm not going to go through all those examples because it would draw us probably till midnight or something. I talked about ambiguity, parentheses, and needing to resolve the ambiguity. By the way, since I first taught this, I was going through a code base that either I or a student had written. And this code base had given the student a devil of a time. Was a graduate student. Devil of a time. It's just terrible. And he was having trouble getting meaningful results, and we ended up taking a different tack for some of the results. It really slowed him down. And I was going through this library, and actually it was in programming language R, which I don't know if anyone here knows about, much less uses, but it's an extremely useful programming language, an extremely popular one. And it had things in it that were statements of sort of, so you can have in R things like, I want, if this is an array, I have an array, and I want to replace elements of the array between, say, 1 and 10 by some values. You can write it like that, or write this, whatever's here, all of those, okay? Similarly, you could say array of, say, m to n, right? And these don't have to be constants. We can do that. So at one point, we had changed this so that I think it was going from something like 1 to to something like 2 times m. And we had just assumed that this would be interpreted as 1 to 2 times m. Actually, how it was interpreted was as 1 in this sort of way. And it was that was the problem, okay? It was interpreting it a way different than we thought. I thought for sure, oh, come on, the binding of this is more, is tighter. And in other words, the precedence of this is tighter. This is higher precedence than this. In other words, we'll evaluate this first. And it turns out that it's really weird. If you have, in this language, if you have n times 2, it works just fine. But if you have 2 times m, it interpreted it as, oh, there's 2, that must be the end of this, and oh man, how many hours were lost? And so all I did is I put this in there, like a charm. Bingo. Oh man. No. Wow, it's a long story, but it had this one silly error may have delayed his getting his master's degree by a year and a half, or something like that. So this is not a small matter, okay? Okay, so use parentheses to resolve ambiguity. Enough said. Okay, and I talked about sort of changing, if conceptually there's something meaningful going on, perfectly give it a name, and you can, if something built in like min that can express this, you're taking the minimum of this, use it. Use it and use it well. I talked about the importance of indentation and spacing, and the importance of making sure you're using tabs instead of sometimes spaces, sometimes tabs. Now, I did talk, ladies and gentlemen, about macro considerations, and because so much of this class is in C and C++, and this may be one of the few places you can get this information before going into the lines then with something like 332, I want to emphasize this. So macros are extremely powerful, but also can be extremely confusing and dangerous. They're like a power saw. You can cut off your arm really easily with them, okay? So the issue here is when you're using a macro, and it could be something as simple as, you don't know whether that's a macro or a function call just by looking at it, okay? And sometimes one macro depends on another and so on. So I talked about some of the dangers of these things. So for example, you might define min as this, and this leads to dangers in a couple of ways. It leads to dangers in the second thing. What's the problem with the second thing? So suppose I have this min defined as a macro. Now maybe the user of it doesn't know it's a macro. They never looked in the .h file. Maybe they think they're calling off to some function somewhere, some library. What's the matter when they write this second one here, this guy over here? Why do bad things happen? Why does that cause bad things to happen? So, okay, what you may mean is, if I could put it another way, x can get incremented twice. You think you're incrementing x once here? Min of x plus plus, you think, oh, it's incremented once. This is a function call. If you're calling off to a function, what happens? Well, first it evaluates this. It says, okay, what's x? Oh, x is 3. Okay, well, I'll increment this. No, it's 4, but I'm passing 3 and whatever the value of y is. That's what that post increment means. It's sort of, okay, use the current value of x, but by the way, go increment it. Go increase it now. Use the original value. Okay, so if x is 3, this will call to a function. The function will get what as its first argument? 3. But x would have been updated now before, but the function call occurs with the 3 as the first argument. The problem is, if this is a macro, it expands to this. Now, why is that bad? It can increment it twice. And the person who's using this may not know that. Suddenly they have 2 increments. Right? Okay, here's another one. Min of xy times 100. What does that expand to? Is that, so if this was a function call, this would be like min of 2 and 1. It would be 1 times 100. It would be 100, right? What does this mean? If it gets expanded, that's what this pound define means. It says, replace this textually by that. This thing gets replaced textually by something as that. So change the spacing a little just to make it obvious, but if this is what it is, and if we had deleted that spacing, it would have been exactly this textually, but this is what it means. So what does this mean? So suppose x is 2 and y is 1. What happens? So is 2 less than or equal to 1? It may be late, but it's not that late, folks. Is 2 less than or equal to 1? No. Okay, so we use this value, right? What is this value? It's actually, yeah, no, okay, this shows, okay, it is late. Okay, so if this were min of 3 and, or min of 3 and 4, it would have yielded a case of min 4 and 3. It would have yielded a case where there should be 300, and instead we get is 4 less than or equal to 3. No. Okay, so it's 4 times 100 is 400. So we get something different from that you don't see this as a programmer. What you see is this. And you're surprised that this is perfectly good, but it means that. And similarly, this guy, what's the problem here? This is calculating 1,000th digit of pi. What's the problem here?
So I was just going to say, isn't there a naming convention that you could use for macro?
Yes, but by convention, C is not used. So they're not distinct. Right. It would be a great thing, and if you were running a C programming project, that would be a great thing to say. Look, we're going to name our macros using, we're going to, at the least, make them have all uppercase, for example, likely to find pound-defined constants to be all uppercase. And I have seen projects, I've seen at least a few projects where that's done over my, 20 some odd years of professional work. But I haven't, it's not uniformly used by me, and I think most projects don't. So what would be the problem with this guy? Calculating it twice. There's your calculating 1,000th digit of pi twice. And pi doesn't change. The value of pi doesn't change, thank goodness. So that's a real problem. I talked about loops here, and there's this convention of using these this thing here to prevent loops and inclusion. So that if A.H includes B.H and vice versa, you don't get an infinite loop. You have this at the beginning of each one. If not def A.H, the A under bar H, then you define it, and that prevents it from being included more than once. Okay, that's just something you see. Okay, time is running on. I talked about a bunch of bad smells in code, duplicate code. Oh man, long routines, things. Basically, ladies and gentlemen, in most projects adhering to really good software engineering conventions, you commonly shoot for 10 lines of code in each function or less. Where does that go? I mean, sometimes you have a lot to do. Where do you do that stuff then? Yeah, you call up another function, which does parts of it. It does nicely named, conceptually unified sort of parts of it. So if you have a lot to do, you just delegate parts of it to different functions, okay? Another thing is having really long or deep if loops, if. It gets all confusing to match up the curly brackets and all that sort of thing, particularly when we're as tired as we are right now. Cases where you have global variables, you don't know what this thing is modifying. You call it with these things each time. It's different because it's changing a global variable. That's a bad indication. Okay, so manifest constants is something I really want to emphasize on. Don't litter your code with constants, okay? So if you have constants in your code, you do a pound define a variable to be that constant, and you use that reference that variable, or you use a const variable in something like C++ or more recent versions of C. And another thing is to separate commands, functions which do something, which change something. They write something to the screen, they send something off via email, they post to a website, whatever. You do that, you separate those from things that just calculate something. Because these calculations, you can call it multiple times, nothing changes. These commands, they actually change something, calling it multiple times does change it. Separating the two is conceptually clear, okay? And more recently I talked about encapsulation, sort of this separation of interface from implementation, etc. I talked about grouping together the uses of variables. So if you have a variable like record index here that's used down in line 26, and you first initialize it up there, that's dangerous because if you're down here, you want to see where it's used, you got to go up like a whole page worth, a whole screen worth to find it. Similarly, if down here is total on line 69, to go up, you have to go find total initialized up here. And it's really confusing. You're looking at all these lines to find where is total last changed, okay? And even if your editor highlights it for you, you got to page up quite a bit maybe to find it. So instead, what's best practice here is to group together sort of where you first initialize this with where it's going to be needed, where it's going to be used, okay? So, okay, if you're not using total until lines, just before this area here, do it just before that area. Bring that down to just before that area. So we kind of group things together. We kind of do things that are conceptually associated with each other at the same time. We talked about idioms. So these are different ways we can do the same thing, but the preferred way to do it is this way. So instead of incrementing I in this loop and leaving this blank and taking delight in C's flexibility, instead of just using a haphazard, sometimes less than or equal to n minus 1, sometimes less than n, we adhere to certain conventions as programmers so that you can read each other's code easily. So here we make it I less than n, not less than or equal to, I less than n, and you have this increment here, and this statement, we don't have lots of side effects with I++ here, okay? And I showed some examples where you can have bugs just by recognizing a deviation. You can recognize bugs by deviations from these idioms. Okay, I talked about magic numbers and so-called manifest constants, so the same thing. The idea here is we should be replacing them by these sort of situations. The problem here, it may seem trivial. After all, can't you do a Control H and replace it all? The answer is no, you can't often. So suppose you wanted to change, this 20 to 40. Why can't I just do Control H and replace say you can just replace all the code in my code base, all the 20s with 40s? Why can't I do that? Why would it be bad? Why could it be bad? Okay, good. So some 20s might be 20s with effect. Maybe this is the number of characters, lines for the screen. And other 20s are, the number of the maximum length of a password or something like that. Now you change them all. Or maybe some of the 20s are 2,000s or 20,000, and now you textually replace it. Even if you have regular expressions, you say it has to be a 20 at the end of a word or something like that, or the entire word is 20, something like that. That's not going to help you because sometimes it may appear also as 19s, and some 20s won't be the same semantic 20s. So what we do instead of, and what's even worse is some of them may be 19s. It's 20 minus 1 conceptually, but the only way you know that is to reason it through. So what we do instead is we create constants with these, and then if we need something like that minus 1, we just write height minus 1. Okay. And it's clear, this refers to height. There can be another 20 that refers to number of characters, or it can refer to length of password, or whatever. And we don't have to worry about confusing those 20s. Okay, I talked about comments as well. The goal is to help the understandability of a program, but you don't want to drown in them. You want it to be explanatory, but not obscure. You don't want it to sort of hide the logic or become so voluminous you're not actually going to read it. Okay? So, and the other piece of it is you want to use clear enough naming so the code is largely self-explanatory. Short functions that delegate to clearly named other functions is going to be very clear. And it's going to be a lot better than a huge amount of code that's commented. Here the idea is to sort of give clarity. Now, this is where, ladies and gentlemen, I stopped in creating my slides. Maybe I'll just look here at some of my other sort of things. Hey, not that one. Some of the other things I went through here. So here, if you want to see these, okay, yes, these are all the regular expressions. So maybe it was up here. Okay. Oh, I talked about testing. So yes, issues of equivalence classes, equivalence class testing, and boundary values. So the notion, ladies and gentlemen, is you want to test some function, for example, or maybe you want to test a UI. You identify what the inputs are, and you identify the equivalence classes for those inputs, And then for each equivalence class, you have at least one representative, right? So maybe it's a square root function, and maybe you think your equivalence class is, well, you know, something that would probably handle pretty similarly is a perfect square. So you give it at least one perfect square. And then you want to give it a positive number that's not a perfect square. And then maybe you want to give it a 0, because that's kind of an unusual thing. After all, that's a fixed point of it. So the square root of 0 is 0. And maybe you want to give it 1, too, because that's kind of unusual, 1. And then you want to give it one negative number and see what it does. See if it signals an appropriate error, or maybe it's supposed to give a complex number or what have you. So here, figure out the equivalence class. This is good. Picking representatives, and then what else do you do besides picking the representatives? You pick the boundaries between them. The things where the programmer might have been a bit sloppy. And by the way, this is huge. By the way, this is something, I got my first job as a professional programmer. This came up in the interview, you know, the issue of off by 1 errors. And these are so common. You tell a programmer, oh, it's an off by 1 error, and they'll know what it means. Meaning you almost got it right, but you didn't handle that one case correctly at the end. So you were off by 1 from what it should have been in terms of handling it. So here we want to test those boundary values, because those often are where our logic breaks down. Okay, so we talked about this and gave some examples. Here. So I also talked about some aspects of style related to this as well. Okay, and I talked about sort of cleaning up some code there. Okay, just sort of covering things. Okay. So I talked about testing, different levels of testing. So there's unit tests, which are typically done by the developers. There's system-wide testing, which are tests end-to-end functionality. Can you open a document, modify the document, and save it, for example? That was sort of the system test. And then there's sort of acceptance tests, which are tests specified often by the user, by the end user, as to whether it's ready to go. They want to give it these files, see if it operates correctly, etc. Okay, so we talked about the notion of a test. What is it? What do we call the code that tests our code? It's a test, scaffold or test harness. And that tests out our code. So we set that up and we run it with a number of tests. And we talked about coverage testing, where we're testing different things. So we're testing paths of the program. We're testing that all conditionals evaluate false and true. We're testing that we reach all statements in the code. We're testing that we execute all transitions in the code. That if we have an if, we have a true way and a false way, for example. Within that if, we have a switch statement. We hit every case of that switch. Okay. So this was text coverage. I'm not heavily testing this, so I'm going to go very light on it. Okay. And we talked about how this could be done at different levels. The level of particular statements. We talked about if statements. We don't want, if we just have statement coverage, just covering going this way is enough. If we want transition coverage, we want to cover both ways. Okay. And we talked about how we can represent a program like this. So we can sort of decompose it and reason about sort of travel over this. Okay. Another thing we can do is we can do that for high-level things. So we could do it for example, an airline ticket reservation. We could do it for an ATM machine or some process. Okay, we're getting to the end. I talked about regression testing and the importance of doing regression testing. What is regression testing, Lisa? Yeah, you want to make sure that bugs that were fixed before stay fixed, and you want to make sure that features that worked before still work. Okay? Because if you break features that the user is using now, it's much, much worse than giving them new features that simply don't work. Because they may have built their whole business around the features that work now, and now you're giving them something that subtracted the value of your program. You've given them something worse than they had before. something where their business can no longer operate. So this whole thing about new features, making sure that existing features still work and that old bugs haven't resurfaced. We do regression testing, which involves often a heck of a lot of testing to make sure these old bugs still are fixed and that these features still are working, but it's absolutely essential to deliver value, okay? So that is something which you're expected to know. Okay, the final thing which I talked about, of course, was just this whole issue of separating interface from implementation, and the fact that carving something off into a function is great, but we really want to specify what that function does, so people don't have to look at all details of it. We specify what it does, they know what they can count on, and we know what we can change in that function. Okay? Ladies and gentlemen, with those words, I conclude this review. I wish you the best of luck tomorrow, and look forward to seeing you on Tuesday. Okay? Good luck. And I'll be posting these things to YouTube in just a minute.